depth, we will specify the bottom of the part, leaving 1/8 inch of stock material. Generating the operation plan directs the TechDB to select the required tools and apply the default machining strategies for each feature. This results in a rough mill and a finish contour mill operation being added to our operation tree. We can now generate the toolpaths for these two operations. Although a great deal of automation was used in this workflow, I still have complete control to override or modify the results. Let's review the elapsed machine time for this rough operation and see if we can improve upon it. Let's change tools from a 1/4 to a 3/8 inch diameter end mill. We can also change our machining pattern to volume mill, high-speed machining. A volume mill can also automatically select my spindle speed and feed rates. After previewing the toolpath, I can now see the decreased cycle time due to my changes. Next, changing the finish contour operation from a 1/4 to a 3/8 inch diameter end mill is easy to do by simply dragging and dropping. After this, the toolpath is automatically rebuilt. So let's simulate our toolpath and view the results. Note the 1/8 inch carrier stock left on the bottom of the part. Now it's time for a full frontal assault using automatic feature recognition. A moment ago you saw me interactively recognize a feature and create two operations. Now using automatic feature recognition, we were able to recognize the remaining 11 features and generate an additional 20 machining operations, all in a matter of seconds. The operations can be easily sorted by a number of criteria. In this case, a simple sort based on an operation list order schema is all that is needed. We can also dynamically reorder our operations in the tree using standard Windows drag and drop functionality. Let's place our 3/8 inch end mill roughing and finishing operations back to back. Next, we can combine similar operations using the same tool on the entire tree, or we can limit our scope to just a few operations. Here I will combine the separate rough pocket operations into a single operation. We can also rename our operations by slow double-clicking the operation name. Before we run our simulation, we can include our vise, our jaws, our grips, and this will help us get a more accurate simulation and a better understanding of any collision that may occur between the tool and our setup. If we do experience a collision, it will appear as a red color during simulation. Now let's zoom in to get a really good look at our toolpath simulation. The tool cutting sequence is in the same order that appears in our operation tree. We can now compare our simulation model against our solid model and check for undercut or overcut regions. The green color you see indicates the toolpaths are within tolerance and we have a good part. It's now time to post-process our toolpaths to create G-code for the machine tool. Solidworks Cam allows us to select the appropriate machine and associated post-processor. Detailed information regarding the post-processor is available to the NC programmer from within Solidworks Cam. The Posting tab contains questions from the post-processor for the machinist to fill in, such as a unique program O-block number to be used in the G-code file. Our technical database stores the critical machine tool specifications. Important information such as the type of machine, the rapid traverse and cut velocities, the maximum spindle speed and horsepower, the number of tools that can be held in the tool changer, and the average time it takes to change a tool. A simple right mouse button on the setup in our tree initiates our post-processor. During posting, each line of G-code is displayed in a scrollable window. After posting, this window can be scrolled and used by the CNC programmer to review the newly created G-code. However, most programmers opt to review the code in our SolidWorks Cam NC editor. Now, this editor allows programmers to efficiently modify G-code when required. Search functions allow us to quickly move to each tool change, and advanced editing functions allow us to renumber, auto-insert spaces, and globally adjust spindle speeds and feed rates. The backplot capability allows us to check for stray tool paths that could affect part quality on the shop floor. And finally, we can review in-depth machining statistics. SolidWorks Cam allows the programmer to create a setup sheet that contains information for the CNC machinist on the shop floor. This can be as simple as a text file or a stylized HTML page. These setup sheets can be customized to include information such as machine details, setup origin, the controller, estimated machining time, part material and stock size, operations, feeds and speeds, and of course tooling information. In this example, we will create an HTML page of just our tooling used in the program. Let's come back and revisit the progress made on our SolidWorks drawing. Post-processing metadata has now been automatically updated in our title block. Let's use the SolidWorks Custom Property tab to add the remaining title block information. Now let's take a close look at our bill of material. SolidWorks keeps our entire set up to date with the proper items, description, part number, and quantities. Let's take a quick look at our notes instructing the operator where to zero his machine and which offset number to use. Next, we're going to do a little housekeeping here. And now we are ready to produce yet another option for shop floor documentation. SolidWorks has the ability to create a lightweight 3D version of our 2D setup drawing for viewing on the shop floor. Our free lightweight viewers can be installed across the manufacturing enterprise. What I love about this format is that the 2D drawing also contains a 3D solid model, which can be animated and interrogated, and then finally printed on the shop floor if a hard copy is needed. So I want to thank you for attending today's presentation. I hope you enjoyed this as much as I did in presenting it. There is so much that wasn't covered in this short video. Please take a moment to visit solidworks.com/product/SolidWorks-Cam for an in-depth understanding of all the SolidWorks Cam offerings and how we can help your company enter the brave new world of smart manufacturing. Thank you, and I hope to see you soon.